when did you first discover Bitcoin, and then how did that lead to you becoming one of the largest private Bitcoin miners in the Western Hemisphere?
So I was in the Seattle, Washington area working in technology, programmer mostly, and I was also doing a bit of trading in foreign exchange. And in my research, I came across this thing called Bitcoin. This would have been about 2011.
Okay.
And in studying foreign exchange trading, you learn a lot about monetary policy and about the way governments are essentially controlling their fiat currency's values. And I discovered that Bitcoin has this fixed money supply concept, which to me meant it can only go up. And this was about when Bitcoin was about $3, give or take. So on the programming side, writing software that runs miners appealed to me. Writing drivers that interacted with hardware really appealed to me. But then also from the trading side, getting into Bitcoin was the obvious thing to do for its deflationary monetary, policy, I guess.
And this would have been 2011. This would have been about the time where Bitcoin in 09, 010 was solo mining without even cards, and then all of a sudden you had the cards that are used for altcoins now. And
right.
then was that just at the dawn of the time
that
the chips came out?
I got into Bitcoin just as GPU was going out. Okay. So I did a little bit of GPU, realized that wasn't the way of things. There was a brief time when technology called FPGA, which is like a programmable chip concept, that was happening. So we did a brief stint there for about 9 months of running FPGAs. And then I had a chance to participate in a big ASIC project, one of the first really efficient ASICs, and had the opportunity to get funding to build one of the first big mining centers in the US at megawatt scale using these ASICs.
So this was Mega Big Power.
That was Mega Big Power. And Mega Big Power's goal was first to try to bring this ASIC to reality, try to discover what would it take to build megawatt scale mining facilities that are not data centers. We recognized pretty early that a traditional data center has a lot of components that add cost, such as active air conditioning, cooling, chillers, redundant power supply, redundant everything. So we recognize that with blockchain hosting, those things are not necessary because blockchains are inherently fault tolerant. If we go down, the blockchain continues on without us, essentially. So we recognize that we could build facilities that were far cheaper on a per watt basis, and also on the hosting side, charge far less for the customers to host their equipment there, if we could optimize these cost centers. And one of the main cost centers was how much do you spend building your facilities, but then even more so from an operational standpoint is how much is your power cost. So I live in the land of hydropower. There's 7 hydro projects in the area of Columbia River where I am situated. And so back when I was living on the Seattle side, I realized I'm 3 hours away from the world's cheapest power.
Right.
And that's what drew me over to Central Washington, got that first megawatt facility built, went on to build 4 more projects after that, and we learned tremendous amount about how to do very less expensive, air-cooled, reliable facilities. And so that's kind of where we got to today.
And Washington State is still in the area of like 2-point-something cents.
Yeah.
I mean, even Niagara Falls doesn't offer that.
Yeah, 2.5 cent power. You'll find places that have less than 2.5 cent power in the world, but usually not at the kind of scale where you can get megawatts of it.
So, and at scale, Mega Big Power got up to how many petahash?
I think we're around 20 at this time, and then now progressing much larger.
So I was a very small baby miner for a while, but enough baby miner, just a home miner, back when that was able to do that in like 2013, 2014, and obviously now you can still do that with altcoins, but you can't do that with Bitcoin anymore unless you're again doing some kind of cloud mining or having a hosted mining. Sort of what Amazon has done to servers is sort of what you're envisioning now that you're going from mega to giga. So tell us a little bit about the vision of
Right.
gigawatt.
So Giga, I'm really excited about. It's just come together very literally in the last weeks, and it's a big project that we're embarking on where up until now I've been what I considered a small business operator, and I couldn't really entertain contracts with the miners who would normally mine essentially at home, where when their miners start to get to where they're not making enough money, they can send it to me for hosting and still capture some value. So I had to turn a lot of people down, and that always felt bad, because I mainly focused on large customers that could do hundreds or thousands of units. So now what Gigawatt endeavors to do is both get, through its partnership, get access to institutional funding that wants to participate in blockchain processing, but as well really get the capital required to provide a proper customer service response for all the small retail miners who would buy as few as 3, maybe like an S9, Bitmain S9 miner, send it to us and get it hosted and maintained from there.
And so the interesting thing as I was studying Gigawatt is, most people think when they're going to get into doing some form of mining that's not in their home, hosted mining, cloud mining, you think of like, okay, what is the Bitcoin miner? What's its life going to be? But it's really interesting that the power is actually the bigger equation, particularly now since we're not doing the Moore's law quite as frequently. And so I was surprised to hear that the life of a typical Bitcoin miner, useful life, is maybe 18 months at the most.
It has been, yeah.
And it's 50 years for a data center.
Yeah. So the interesting thing there is that the data center lives on. The watts that we build are reused, and more of our infrastructure that we consider infrastructure is staying in place. So, for example, it used to be we would build infrastructure to a large plug where we could plug in a power strip and plug in a bunch of miners from there. Now the definition that we call our infrastructure goes all the way down to the power supply, and then we're even to some extent we're replacing cards within the units, and we're now able to repair those units, which is a big thing. As we get to be a very large operation, you really need the ability to do on-site repair. You can't be packaging these things up and shipping them and incurring that whole cycle time of shipping them for repair and getting them back. So we're trained, we're actively repairing these things, so that's a big enhancement to the business as we scale up.
Okay. And trying to be as educational as possible and not promotional, you basically have two different aspects of this new business. You're going to have a Gigawatt offering to miners who can send their miners in, or that they can lease a miner as well as lease the power. And then you're also going to have, sort of in its final stages, ways that people can participate in the life of the 50-year power.
Right. So through my partnership with this excellent group, the new group on the scene, there will be a token that will allow an investor to access the investment in the watts, in the actual power infrastructure, which is a really unique opportunity because it gives that long-term type of return on the investment. And they can combine mining with the investment in watts to further enhance their overall investment. We're also, by the way, I wanted to make it clear that we're focused on not just Bitcoin mining. Bitcoin mining was the app that allowed us to get to where we are today, and it is a great application for its specific purpose, but there are many more blockchain apps coming out. I'm kind of fond of saying that Bitcoin and Ethereum kind of created the first billion-dollar blockchains, the unicorns of crypto. But there will be many more. We know this. And what we also know is that the proof of work algorithm is the current de facto standard. It's the one that's winning. That's the one that's getting the value into the blockchains. And the amount of mining power that's processing on this blockchain is proportionate to the security of that blockchain. We also know this. And so the amount of value in assets that can be secured by that blockchain goes up proportionate to how much processing is done. So all of those things to me means that there's a progression coming where more and more apps are built for blockchains and more blockchains are hosted in facilities like what I'm building.
Now, obviously, some proof of work algorithms are meant to resist the larger scale mining with different forms of script X and things like that. What types of coins other than Bitcoin, Ethereum, maybe Dash. I mean, we'll be able to work at scale of the current coins out there.
I'm really excited about the GPU-based stuff because it's so programmable. That was what I got started on, and I was playing around with.
Oh, so you can basically put in GPUs to this facility as well?
I do have quite a bit of GPU mining.
Okay.
So I think that people will be able to mine. People are currently already able to mine Bitcoin, Ethereum,
Right.
Monero, Zcash.
I was going to ask about Zcash. So
Yeah. So
somebody could go in without having to go and do all the setup of this, get really lower power than they have at home, and have a managed service.
right. In most cases, our hosting price per 1,000 watts per month is cheaper than they would pay just for their power. So there's real no incentive to run at home
Right.
in that regard. While at the same time, we're looking for ways to try to support decentralization. So we know there's this trend towards centralization of mining. We're trying to create a balance of that power between, say, China and the U.S., for example, and give U.S. investors and consumers a place to put their hardware that they feel really comfortable about.
What's the how big can the hydroelectric in the Pacific Northwest grow?
It can go huge. I mean, our project right now that we're just embarking on is 30 megawatts,
Okay.
quite a bit bigger than I currently am, and then it goes over 100 in the timeline in the plan. So, and we can easily support that much in that area.
Okay. Great. Well, I think we're about out of time here.
Okay, great.
And thank you very much.
Yeah, thanks, Michael, and thanks everybody for listening.